Okay, this entire chapter is on factoring, so we're going to break it into chunks, and it is going to be pretty important because the next few chapters are going to involve factoring. So we're starting off with factoring the GCF. So the bell work says list all factors of each number in increasing order. So if I'm listing the factors of 16, I already have 1 and 16 listed, so I would also have 2 and 8. 2 times 8 gives you 16, and then 4 times 4, but I don't have to make copies of it, so I'll just go like this. Okay, and then the factors for 24, I've got 1 and 24. That's the smallest and the biggest factor. And I have 2 times 12. And I have 3 times 8. Oops, I want to put a 3 first so I can go in order. 3 times 8. And then I have 4 times 6. Now there's also 6 times 4, but that's the same as 4 times 6. So once the list starts to repeat, I don't have to keep going. So it says simplify the following fraction, and what I want to tie this into is if you don't know how to reduce a fraction, it all ties into your greatest common factor. So if you notice in the fraction, I have a 16 and a 24, and those were the same numbers I used in the bell work. If we look at what a greatest common factor is, a greatest common factor, if you tear apart the words, greatest means biggest, common means they all have it, and then factors are the things we multiply to get the number we want. Okay? So if we look at the factors of 16 and 24 and we start from the right, we always want to start from the right because we're looking for the highest number that they both have in common. You're going to see that they have some 8s in common. Now the cool thing about this is if they both have 8s, if you look at what was multiplied with the 8 to get to 16, and the same thing with this guy over here to get to 24, the numbers over here are what this fraction would actually reduce to. It would reduce to 2/3. The reason why is because when you reduce a fraction, all you're doing is dividing out the greatest common factor. So with that being said, if you want to find common factors, you just have to list the factors. You're going to notice that some of them have multiple common factors. That's why we don't go from left to right. We want to go from right to left because we want the greatest common factor. So that means the highest one. So if we have the greatest common factor in this problem, it's going to be the 6 because it's the highest and they both have it. So what we do here is we're going to take a look at some problems where they ask us to take out the GCF or factor the GCF. Anytime you factor a GCF, you have to write it in the front of a set of a parentheses. So it's basically like we're undistributing, but we're going to take out the biggest number possible. Now in the first example, they're both 7s, so that means I can divide them both by 7. So 7 would be the GCF. So the 7 goes in front, and then if I just do that division problem, I'm left with x minus 1. Now if I have 36 and 12, technically I don't really have to make the list for both of them. I can kind of just go off to the side and make the list for 12. So the list for 12 would be 1 and 12, 2 and 6, and then 3 and 4. Now in order for this to be a GCF, we already know it's not going to be any higher than 12 because I wouldn't be able to divide by 13 or 14 or 15 or 16. It has to be 12 or something smaller. So I'm only going to break down the 12. So can 36 be divided by 12? Actually it can. So 36 divided by 12, if I go into the calculator, 36 divided by 12. And I'm starting from 12 because I'm trying to find the greatest common factor. Now if that gave me a decimal, I would have went down the list until I found one that works. So now, since I know 12 actually works, I can take out the 12 from both terms. It goes in front. And then the result to these division problems would be 3x minus 1. Now GCFs work on pretty much anything. Doesn't matter if it's a binomial or a trinomial. That just means it has 2 terms or 3 terms. It could have 4 terms. Doesn't matter. Any problem could have a GCF, so that's why we're starting the chapter with GCF. Now the cool thing about this is I already have the list for 12, and 12 is the smallest number on this problem. So what we're going to do is we're going to see maybe if we can get this to work on the next problem. So if I tried 12 24 can be divided by 12, but it has to work in all of the terms. 18 cannot be divided by 12. If I show you in the calculator, this is what it would look like. 18, I go 18 divided by 12. It gives you a decimal. So we can't use 12, so we have to go smaller. So we try 6. 24 divided by 6 works. 18 divided by 6 works. And 12 divided by 6 works. So 6 is actually going to be this GCF. Now, if you don't have, ooh, that's scary. If you don't have good multiplying or division skills, I've got a workaround. So check this out. If you just go into your calculator, you can actually find the GCF in your calculator. Let me clear this out so I don't confuse you. So if I want to find the GCF, I'm going to have to hit the option button. Then I'm going to hit the arrow to the right until I find number. So NUM is F4. And then I'm going to hit the arrow to the right, which is F6 one more time. And then we're going to hit F2 for GCD. GCD is like greatest common denominator, but it's the same thing as the greatest common factor. So if we hit that, we would enter in 12. If I can, 12. And then we use the comma button. It's right above the delete button. And then we're going to put in the 18. And then we're going to, if this responds to me touching it, there we go. And then we're going to go and put another comma, and then we're going to put in a 24. So if I close my parentheses and I just hit execute, it tells me that the greatest common factor is 6, which we already found. So that's just another way you could do it. So we've got 6, and then we're going to take out all the 6's by dividing. So this would be 2. This one had a y squared. This one would be minus 3. This one had a y. And then the other one would be plus 4. So that would be your answer. Now, I purposely chose large numbers. I don't want to break down 128, 224, 3,380. So I can actually just do that one in the calculator. And that's why I like the calculator. So I'm going GCD, which is F2. I'll type in 128. And then I have to hit a comma, which is above the delete button. Then 224, comma, and then 3,380. And I hit execute, and that tells me that the greatest common factor is going to be 4. So I can divide this by 4, divide this by 4, and divide this by 4. Now with numbers this big, I don't know what those answers are, so I got to do this in the calculator. So 128 divided by 4 is going to give me 32. So I'm going to have to stick the GCF in the front. So the first one is 32x squared. And then I need to do 224 divided by 4. 224 divided by 4. And that one gives me 56. So this is going to be minus 56x. And then I have 3,380. So 3,380 divided by 4. So we end up with 845. So that's going to be minus 845. Okay. So then if you turn to the next page, I'm going to show you how to find the GCF in terms of the variables. So if we have to take out a GCF of a variable, what we're going to do is we're going to check to see if all terms have the variable. That's the only way a variable can be a GCF. So I'm going to show you a visual way, and then I'll show you a shortcut. So let's take x to the 4th. X to the 4th just means that there's 4 x's altogether. X to the 3rd means there's 3 x's altogether, and then x squared means there's 2 x's altogether. So the number of common x's is going to be 2. Every single one of these has 2 x's in it. So we can pull out the 2 x's. So we would pull out x squared. And actually, you know what I'll do? I'll go ahead and divide that out. So I'll divide out an x squared here, divide out an x squared here, and then divide out an x squared here. So our x squared, it would go in the front. And then I really like this visual because this shows you there's 2 x's left, so that's another x squared here. This shows you there's 1 x left. So I'm going to put the 3, because remember this one has a 3 on it right here. So I'm only taking out the letter. So I have 1 x left over. And then the other one, if I do x squared divided by x squared, that just gives me a 1. So I'm left with just 1. So that's the long visual representation of taking out a GCF that's a variable. Now I want to show you a shortcut. The catch here is, number one, all terms have to have it. Okay? If all terms have it, then what we're going to do is we're just going to take out the one that has the lowest exponent. That's what it's going to work out to every single time. It's going to be the lowest exponent. So in example 1 here, I have an x and I have an x here. So they both terms have it, and the lowest exponent is x to the first. So I'm going to pull out the x. If you just divide it out like this, so that would leave me with an x and then a minus 12. And then same thing over here. If you look, this one over here, this one has an x to the fifth, but the other term doesn't have an x, so I can't take out any x's. So I should be able to take out some y's because this one has a y and this one has a y. Lowest exponent would be y squared, so I'm going to take out a y squared from here and a y squared from here. So the y squared goes in the front because GCFs always go in the front. Then we're going to be left with x to the fifth. If this one had 3 y's, that's what x to the third means, and I take out 2 of them, that means I'm going to be left with a y. And then if this one had y squared, that's 2 of them, and I'm taking out both of them, I'm just left with 1. Okay? Third example here, oh, it's packed with stuff. Oh, it looks like that other problem we looked at. Okay, so let's start with the x's. Can we take out x's? I see an x right here. I see an x right here. I see an x right here. So I can take out some x's. It's going to be the one with the lowest exponent. So I'm going to pull out an x. So I'll take an x out of this. I'll take an x out of that. I'll take an x out of that. And then I'm going to pull out the y's if I can. So I'm going to look at the y's now. So this has a y. This one has a y. And this one has a y. Lowest exponent is y squared. So I'm going to pull out a y squared. Pull out the y squared here. And then the last letter is a z. So this one has a z, but that's the only one that has a z, so I can't pull out any z's. So my GCF is going to be x and then y squared, so that goes in the front of the parentheses. Now this thing had 3 terms, so the parentheses should have 3 terms. So I'm going to be left with x to the third, I'll be left with y squared, and then the z to the fourth. And then I'm going to have the 224. I'm taking out one of the x's and it had x to the third, so now it's got x squared. And then it's going to have a y left over. I should have made my parentheses bigger. Let me just fix that. So this is going to be minus 380. And then all of the x's are gone and all of the y's are gone. So this right here would be my final answer. Now here's the catch though. When we see our problems, it doesn't matter how many terms they have, it could be a binomial or a trinomial, we have to always check if there's a number and a letter, because there is the possibility that could have both. It could be one, the other, or both. Okay, so here's how this is going to work. We're going to take a look at, let's start with the number first. The smallest number here is 1. Anytime the smallest number is 1, there really isn't a GCF. I mean, you could use the 1, but if you divide by 1, nothing happens. So we're going to take a look at the letters now. So the letters, I've got x here, I've got x here, and I've got x here. So I can pull out the x. Now if I take out one of the x's, I'm going to be left with 3x squared plus x minus 12. So I'm not messing with the numbers at all because I didn't divide any of the numbers out. There's no numbers in front at the GCF spot. Okay, next, let's take a look at the numbers. So the smallest number here is 3. And you could use the calculator, 3, 27, and 9. You could put that into the GCF and see if there's a GCF. But 3 is going to be your GCF. So you can divide all these by 3. And then can I take out a letter? This one has an x, this one has an x, but this last one doesn't, so I can't take out the letters. So I'm going to take out the 3 that goes in front. And then I just put the result to the 3 division problem. So this is going to be an x squared here, a plus 9x here, and then plus 3. Okay, last problem. Looks messy. So I've got a 6, an 8, and a 12. 6 is the smallest number. You know what? I'll review the calculator one more time. Let me show you how to get to that stuff. So I'm going to hit exit so I can clear all this out. So to get to the greatest common factor button, you're going to hit option, which is next to the yellow button. Then you're going to hit F6 to arrow over to number, which is F4. and then you're going to arrow over to the right again, so it's F6, and then you're going to hit F2. So if we find the GCF between 6, 8, and 12, and then hit execute, the GCF is going to be 2. Now, the downside to the calculator is it only does numbers. We have to know how to do the letters ourselves. So looking at the letters now, I see a Y there. So first term has a Y, second term has a Y, third term has a Y, so I should be able to take out the Y. And we're only going to take out a Y because the lowest one is Y to the first power. When you look at the X's, the third term does not have an X, so we can't touch the X's. So that means that the GCF goes in front. It's going to be 2Y. And then I have to divide, so this is going to be 3. This had Y to the third, and I took out a Y, so it's going to be Y squared. And then I didn't touch the X's at all, so that's X squared. 8 divided by 2 is 4. This had a Y squared, and I'm taking out one of the Y's, so now it's just Y. And then it also has an X on it. And then plus 12 divided by 2 is 6. And I took out the last Y, so it doesn't have a Y anymore. So that's pretty much it with the GCF. So you could just use the GCF function in the calculator. Just make sure you know how to get to it. And then for the letters, you got to make sure they all have the letter. And if they all have the letter, then you just pull out the highest exponent. And that's how you do GCF. So it should be pretty straightforward.